So now we're looking at simplifying rational expressions, and that starts with factoring the numerator and denominator completely. So we'll rewrite this rational expression here, x squared minus x minus 2 over x squared minus 3x plus 2. So with our numerator, we want what two values multiply, since our leading coefficient is 1 in both of these polynomials in the rational expression, the numerator and the denominator. We know that we're going to have binomials. We know the leading term is going to be x in both cases. Now, what two values multiply to -2 and add to -1? Well, that would be x minus 2 times x plus 1. Similarly, in our denominator, we have x squared minus 3x plus 2. We want to know, well, first off, we know that the leading terms are going to be x because we only have x squared. The leading coefficient is 1. And we want to know what two values multiply to 2 and add to -3. Well, since we're adding our constant at the end and we're subtracting our x term, we know these are both going to be negative. That's the only way to get a product that's positive and a sum that's negative. And then with 2, we don't really have any options. It's just going to be x minus 2 times x minus 1 because it's a prime number. So then when we simplify this, now we first need to note this automatically means we don't want to forget x cannot equal 2 and x cannot equal 1 because x minus 2 equals 0. If we solve for that, we get x equals 2. X minus 1 equals 0. We solve for that, we get x equals 1. So x cannot equal those values because we would end up with a denominator that's 0. So we cancel our like factors in both the numerator and denominator, and we're left with x plus 1 over x minus 1, and then we need to note what we already wrote down here. X cannot equal 2, and x cannot equal 1. And if we wanted to check this, we could multiply back through, but we'd essentially just be working backwards from what we've already done. You could also graph the rational expression, but we haven't learned how to do that yet, technically. So for now, when we simplify rational expression, we factor the numerator and denominator completely. We cancel like terms, and then we write what's left, and then note anything that would make the denominator 0 because it's undefined there. If we plugged in x equals 2, and we can go ahead and do that real quick. Let's go ahead, and if x equals 2, this will kind of partially verify our factorization as well. So 2 squared minus 3 times 2 plus 2, that equals 4 minus 6 plus 2, which equals -2 plus 2, which equals 0. And if x equals 1, we'd have 1 squared minus 3 times 1 plus 2, which equals 1 minus 3 plus 2, which equals -2 plus 2, which again equals 0. So that verifies that x can't equal 2 and x can't equal 1 because it would yield a denominator of 0.